All right, guys, so this video is about solubility and understanding how to plot the solubility curves, understanding what is meant by the term solubility, how to define it and its units, as well as interpreting the graphs and plotting them. So solubility is the ability of a substance to dissolve in a solvent, and therefore it is measured in grams of a solute per 100 grams of a solvent. So over here, if you have 23 grams dissolved in of a solute dissolved in 100 grams, so it's basically 0.23 grams of solute per 100 grams of solvent. So it's very important to know the units and focus on the units as we see over here on the axes. Okay, and this is a plot of the solubility according to temperature. So as you change your temperature, what happens to the solubility? So solubility of most solids will increase as you increase the temperature, and therefore here we have a graph of solubility versus temperature, and we call that the solubility curve. All right, now we can see here from the points that at zero temperature, the solubility was 25 grams per 100 grams of water. And then, for example, at 80, it was, and then you come over here, you can see that it was 54. Okay, now you can use these curves to see the solubility at a specific temperature, or even backwards. You can go backwards and say, okay, whenever I have this solubility, what would be the temperature? So that's called interpolation. So when you use the graph and you use dashed lines to show how you got your answer, and you will use your ruler in that case. Okay, so basically now, and so here, yeah, that is interpolation if you want to pause and look at this. Now, here we have, there's another page that I want to show you now, which is this one, the plotting bit. Now, to plot, you're going to be given data, which is basically the solubility and then at different temperatures. So these are the different temperatures, okay? And then you have your two different salts, for example. It could be one salt or more than one, but here, for example, you have a salt of sodium chloride and copper 2 sulfate, and you would plot a graph of their solubilities. So use the data below to complete the graph of the questions on the following page. Therefore, I'm just going to do here a rough sketch of how these axes should be like, and you have been trained to sketch these using a ruler. I'm just going to show you roughly speaking, and like I told you before, you can use your hand to place it, the palm of your hand to place it here on the paper, so it should cover, your graph should cover that size of, let's say that's the palm of your hand, it should cover that size of the paper if you put it on the paper. Okay, so for now you're going to have to look at how to divide your axes. Now, your temperature is going to be on the x-axis. Obviously, you're going to use pencil, so temperature is going to be with the units over here, and on the y-axis, you're going to have your solubility. So you're going to have to label your solubility, and that is in grams per 100 grams of solute. And you have to see now when you divide your scale how much space you need, okay? So you have to see the highest number, lowest number, and work accordingly. So your temperature range is between 50 and 10, but you can start from 0. There's no harm for temperature. So you can work with a range of temperatures on the x-axis from 0 all the way up to 60, 100, because you may need to extend the curve, okay? And then for the solubility, you have a range going from the lowest being 27 and the highest being 55. And therefore, you need to divide your scale accordingly. Okay, so if you have 50, let's say the highest solubility is 60, let's say, not 55, and then your lowest is let's say 20, you can divide your scale between a range of 20 and 60, and you can start off at 20 and then you go up, you know, up your scale accordingly. So you can say if that's 20, then that could be 30 for you, and then that could be 40, and then that would be 50, and then that would be 60. But that looks like it's a very small scale. So we don't want them to be all crammed in such a small space. So what would we do? We can use the space differently. So you can space them out in that case. I'm just going to use a different color here. So I can start at let's say 20. Sorry, pen's getting stuck. 20. Okay, and then I can use 4 here. 1, 2, 3, 4, and that would be like 30. 1, 2, 3, 4, and that would be 40. 1, 2, 3, 4, and that would be 50. 1, 2, 3, 4, and that would be 60, which means every small square on the y-axis is 2.5. Okay, every small, because between the 20 and the 30, it's 10. So 10 divided by 4, every square is 2.5. Okay. Now on the and I didn't start at 0 just because the solubility doesn't get to 0. And then on the for the temperature, you can start from 0, and then you can go 1, 2, 3, 4, and then that could be your 10. Then 1, 2, 3, 4, and that could be your 20. 1, 2, 3, 4, and that could be your 30. 1, 2, 3, 4, and that could be your 40. 1, 2, 3, 4, and that could be your 50. 1, 2, 3, 4. I don't think, oh no, it goes to 60. Okay. And that's it. Now you need to start plotting, and plotting wise, you have to identify 2 points and then make the point between them. So 10 and 33. So at temperature of 10, you had to be on, you go up and then you look for the 33. So if that's 2.5, then 33 is just right above that. You make your X. Okay. Your next one is at 20 and 35. So 20, you go up, and then 35. So it's two squares above the 30, because every square is 2.5. So that would be an X. Okay. And then at 30, you have 36. So I'm just looking at the data here. 30, you have 36, which means if this is 35, and that is 37.5, so it might be here, just a little, okay, below. And then you have at 40, you have 37, so it is right below that line here. And then at 50, you have it's also stuck on 37. Okay, that is for one graph. And this is what you have so far. So what you have now is you don't have the line. So it's basically like and what we have over here is like a curve-like shape. So it needs to be clean, okay? And it needs to be in pencil. And you want to try to connect them as you want a smooth curve. And so you want to connect to make it go through the maximum number of points as possible, okay? It should be, if zoomed in, it should look more like a curve, but because they're squished, it doesn't look like a curve. And that's why I always say make the scale bigger, okay? So you should get something like over here. The reason why we couldn't see that is because the scale is very small. So if you have a bigger scale, you'll be able to see that curvature, okay? Now, going back to this one. So at this point, you do not have the data on here, and you do not have the data here. However, you see a trend with the line, so you could extend it, and we call that extrapolation. So you can actually extend that line with your own hand if you continue to see a pattern, okay? So that value, they could tell you at 0 temperature, what was the solubility, you know? So that's one of the things that you could do. So like here, you can, and then, and so forth. you could do the same now for copper 2 sulfate, and you can compare. You can tell that copper 2 sulfate solubility starts lower, but then finishes higher, okay? And then at which temperature do they display the same solubility? At this point, let's say, I'm just going to sketch the answer, okay? So if one is like 27 over here, let's say it's like this, okay? That would mean, and I would have to label that this is CuSO4, and the other one is sodium chloride, okay? So where would they display the same solubility? It's where the lines meet. The greatest change in solubility is the one that shows the greatest change in the y-axis for us here, okay? So it's copper 2 sulfate. And then how much sodium chloride would dissolve in 50 grams of water if the temperature was 15? So we're going to go find the, for part D, I skipped D because, C, sorry. C is easy. I can do C now, which is basically you want to find the solubility of the salt at 25. So you're just going to go on 25 and then you're going to read how much that is on the y-axis. You know this. But the other one is finding the solubility. How much will it dissolve if it was at 50 degrees, okay? And in water. 50 grams of water. So at 15 degrees, you're going to go and look at your graph here, and you're going to see this value on the y-axis, which basically looks as 35. Okay, so the solubility is 35. However, therefore, for sodium chloride, the solubility is 35 grams per 100 grams, and this is at 15 degrees Celsius. However, if I have now 50 grams, okay? What will that solubility be at the same temperature? All you're going to do is cross multiply. So 35 in 100 grams. How much would that be of water? Okay, so that's because that's sodium chloride, and that's water in water. How much will the solubility be if I had 50 grams? So by cross multiplication, you're going to do 35 grams times 50 grams divided by 100 grams. And that is basically how you would do it. So basically, it's half the value. Okay? Now, to investigate the solubility like lab-wise, you need to saturate the solution. To saturate the solution, sorry, you're going to add an excess of the salt, okay? And you would know that it's in excess because it's going to sink. And then you can stir it and place it in a water bath, or you can heat it under a Bunsen burner. And after you evaporate some of it, okay, you're going to see that the solution becomes thicker and more saturated. And saturated solution is when no more of that solute can dissolve at this specific temperature. And then you are going to if you stop and look at these steps, so basically you're going to weigh an empty evaporating basin. You're going to pour some of the solution in it, and it's this is basically just the water. And then you're going to reweigh it after heating it. Okay, you're going to keep heating it, and then you're going to reweigh it once you have evaporated some. Okay, and then you're going to see the total mass with the evaporating basin. And then you will see how much of the solid was left. You're going to repeat these steps at different temperatures. Okay, so if you pause the video, you can go through these steps. You also have these with you in your paper. But over here, you can tell that the mass of the basin is given, and the mass of the basin with a saturated solution, then the mass with the solid. So to get the leftover one, you will subtract the mass of evaporating basin with solid minus the basin, okay? And if you want to get the amount of water that we got rid of, it will basically be these two, which are basically the total mass of solution with basin minus that of basin with the solid. So this is how much evaporated. So to calculate the solubility, you need to divide the mass of the solid divided by the mass of the water that was removed. Okay, so how much water was removed for you is over here, the one that evaporated, and then the mass you got from that. So you can pause the video and you can study the data for your own analysis. So that will give you this value eventually. And then it can be repeated at different temperatures and you can compare. So this was the lab that we did. And you can have a look at it. You can read through the steps with the equation of the mass of the solid divided by the mass of the solubility. And as we conducted you don't have to do the data, but I would like you to just go through these steps, which is basically weigh the mass of an empty evaporating basin and record this. Add approximately 50 cubic centimeters of water. Using a spatula, add the solid you have been given and stir with a glass rod until no more dissolves. The solid will be in excess, so you will know that some of it will be undissolved at the bottom. Set up a conical flask with a filter funnel and filter the solution. Pour the filtrate into an evaporating basin and weigh both together. With the evaporating basin, it means like the solution and the filtrate. Record the value on your table. Heat the evaporating basin gently until the water has evaporated. And then when it looks like all of the water has evaporated, weigh the evaporating basin and its contents. And then make sure all of the water has accurately evaporated. So you heat it and reweigh it until the mass is constant. And then you will carry out the experiment again, but at least with different temperatures of water. And then as you at a specific temperature, you have the mass of the basin and then mass of basin with filtrate. And then eventually after you have the solid, then you will subtract these like we did in the previous step to get the mass of each one. And then the solubility is dividing mass of solute over here, solid divided by the mass of the water. Then you're going to take your solubility, okay, and you're going to take your temperature and you are going to plot them over here. So here you're going to have your temperature, here you're going to have your solubility on your y-axis, okay? And these pages, I'm actually going to share them with you for you also to have a look at. All right, thank you so much. I hope this was helpful.